right, good morning. I hope you guys had a good weekend. I am going to talk about the last section of 8, chapter 8. There will be one more section two more sections for this chapter. But this is the last one from chapter 8. So it's just about other theorems that we can use with proportionality. If I've talked to you at all, one-on-one, I've said something along the lines of everything we do from here on out is going to be ratios. If we get to circles, we won't really use ratios, but what we're thinking is we'll probably just do a little bit of circles, but mostly just start with trigonometry. Trigonometry is all about ratios, and so these are just other ones that we can look at ratios. It is technically 3 different theorems, but we're just going to, I think really these two are the same, and I'll talk about why here in a second. There's proofs that for exercises. I'm not worried about the proofs right now. This is more just being able to identify and see the ratios. Let's look at these. These are the 3 theorems that we'll look at. There's one, these top 2 deal with parallel lines, so we'll be looking for parallel lines. And then this one down here looks for an angle bisector of just a single triangle, so we'll be looking for that. So let's go through and look at some examples of how to use those. So here are the first 2, and I'll talk about why they're the same, but let's go through the examples. So really, we have the first one here. We have a triangle. We need a triangle. We have parallel lines, but notice how it's different. We could use our similar triangles. We know these lines are parallel, so I know that this angle and this angle are the same, giving me angle similarity. And so I could say 79 over 44 is going to be the same thing as some distance over 36, and then subtract it for x. We've done that before. But now what this is saying up here is that if you actually have parallel lines, all you're doing is just adding these together. So I could take RT over TQ and set it equal to RU over US. So I can set this up and say, hey, 44 over 35 equals 36 over x. We still keep the same thing, still keep the ratios. The smaller side, or I guess it's not the smaller, the top side of that is across from the corresponding side. We keep those ratios the same. And then we can cross multiply, and I get 44x equals, anybody know what 36 times 35 is? It is 1,260. And then divide by 44, and we get 28.6. I think I did something wrong. Let's see if I can figure out what it is. 44 over 35 equals 36. Well, looking at the book, I was just thrown off as you guys are that it's a weird decimal, but that is correct. And so we will we'll keep that. But so make sure that we're setting that up and setting the ratio up. Now, as we look, we have this one, 3 parallel lines. I just feel it's silly because it's the same one as this one, except there's 3 parallel lines. And why do I think it's the same one as this one? Well, because if we extend this line out, well, look, it becomes a triangle. And so nothing's different, it's just adding another parallel line to it. So, you know, it's different, it's there. But we can set up the same thing. So if I set up the ratio, I'm going to take x over 2x plus 3. X over 2x plus 3 equals, the side corresponding is the 6 over 14. We could reduce this, but let's just go with it. So I have 14x equals 12x plus 18. Subtract my 12x and I get 2x equals 18, giving me x to equal 9. And if I go back up here, I can plug those in and I can say that x equals 9, and this one is going to be equal to 21. So there's the ratios. That's what we're doing. Setting the ratios. No longer we have to go full side. But I could say, now that I know that, I could say 20 over 14 is the same thing as 30 over 21. I can now break this up in any way I want. I just have to make sure I'm taking the correct sides of the triangle or the three parallel lines. The last one is this guy, angle bisector. So if we look at here, what it's saying is I can take the angle bisector, the side being bisected, I can compare those two sides, compare those to the other sides of the triangle. So we can look down here, and I want to find x. But what we notice is that I don't really know QR. But what I do know is that if this is x, whatever length this is, if this was 10, this would be 5, right? 15 minus 10. If this was 9, this would be 6, 15 minus 6. So I know that this right here is going to be 15 minus whatever x is. And now I can set up my ratios. I'm going to set up the bisecting sides first. So the sides being bisected, I'm going to take 15 minus x over x. I'm going to set that equal to, well, if I look, it's the sides being bisected, and then I set the sides right next to it. So the side right next to this 15 minus x is that 7. So I'm going to set it equal to the 7 over 13. Cross multiply, and we get 7x equals 15 times 13, 195 minus 13x, so forget that minus. So I add that over, and I get 20x equals 195, and that gives me my x to be 9.75. And so that will be whatever length x is. So we want to make sure we set that up. This is the big idea in here, but we're just setting up ratios. Just look for those ratios. Make sure you're looking for the certain things. If we go all the way back to the beginning slide, you're looking for the sides compared to the sides cut up in both of these. But this one we're looking for, we're going to compare the two sides compared to these two sides. So use those in your in the homework below, and I hope it's not too challenging, and we will see you later.